Our vision is a general purpose robot, one that can go anywhere, understand its surroundings, and manipulate anything. We're building a tool that can work anywhere in a facility from dock door to dock door. We want the robot to not just be able to do one job, but to be flexible enough to change as business demands and needs change. We envision a world where factories are software defined and where robots collaborate with people. In this video, you'll see Atlas working alongside Spot, alongside Stretch, and alongside all sorts of other AMRs and robotic systems that exist in Hyundai facilities today. We believe in a future where factory work is redefined and made more optimized based on the optimizations that we get from having humanoid robots and other types of robotics and software solutions installed in facilities. We're starting in industrial environments first, but the way that we train this robot to do this type of work is extensible to all types of work in all types of industrial settings and beyond. We believe that this will lead to the next industrial revolution, and we're bringing partners together that are the best in the business in each of the core competencies you need to actually bring a humanoid solution to life that's valuable to customers. We're bringing Boston Dynamics production-grade hardware technology to the table when we're bringing our humanoid into facilities. We announced on Monday our partnership with Google DeepMind, who's industry leading in the AI space and will help us accelerate Atlas's out-of-the-box intelligence, making it easier for us to deploy Atlas faster so that we can provide value to customers sooner. And of course, our partnership with Hyundai allows us to scale manufacturing and learn from real-world factory data. Hyundai is enabling us to deploy Atlas in a way that we've never imagined before. We are building operational robots, not science projects. But to do that, we have a lot to think about and a lot to build. We've been at this robotics thing for a while. We have Spot out in the world in thousands of customer facilities. We have Stretch out in warehouses today, moving millions of boxes and trucks. And we've learned that it takes more than just hardware to actually deploy a product to customers. It takes hardware, software that enables the robot to learn new behaviors and learn new tasks. That's the AI brain that everyone's talking about and is so excited about. And it takes application software. Atlas needs to be talking to your manufacturing execution systems, your warehouse management systems, because we're moving and touching your inventory. Atlas needs to interface with people. It needs to tell operations teams that it's doing the job right, that it's doing the job the way it's supposed to. And it's even more complex than that. Your hardware and your software, when you deploy robotic solutions, needs to be reliable. Each component of your solution needs to be reliable if you're going to work in manufacturing facilities. It needs to be predictable. Operations teams need to trust that the robot's doing what we said it was going to do, and that it's following the rules of the road in the facility. It needs to be safe, and it needs to be deployable. If we're going to scale the way that we want to, we need to make it quick to drop these robots into your facilities and to get them up and running. This is the robot that we announced a year ago. This is our first electric generation of Atlas, and this is a robot that we've been using over the last year to train and learn all sorts of new skills and tasks. This is a robot that we are actually demoing across the way throughout the day. So definitely take a look if you can. If you want to see this robot get up live in person and do real industrial tasks. This is also the robot that we brought to the Hyundai Metaplan America facility in Georgia just a few months ago, where we did live industrial work for the very first time. We've taken the learnings that we've gathered over the last few years to develop a version of Atlas that our customers need in their facilities. We're generating a version of Atlas that actually can do challenging, ergonomically unfriendly, and increasingly difficult to staff tasks. This robot can pick and place parts up to 50 kilograms or 110 pounds. It has an onboard safety system with 360-degree cameras so that we can promise a safety solution that really works the same way that we do with Spot today. It has a 4-hour battery life and continuous operation capability because Atlas can actually swap its own battery. opinion, most importantly, this robot was designed from the ground up with reliability, manufacturability, and serviceability in mind first. This means that we designed this robot intentionally to be easy to build, easy to fix, and really reliable for our customers so that it's there when they need it most. There are all sorts of specs that are very, very exciting about this new robot. One of those is how tall it stands. It's over 6 feet tall and can reach 7.5 feet in the air. This enables Atlas to drop into any facility and do work that's really high or really low on the ground. This is an IP67 robot. For those who don't know what that means, it means you can wipe down the robot and clean it up. It's water resistant. And it can operate up to 104 degrees Fahrenheit and down to -4 degrees Fahrenheit. This means if you have a facility that's not air conditioned, Atlas can do hard work in that facility. Atlas has field replaceable limbs in less than 5 minutes, meaning if something goes wrong, we can get a robot back up and running extremely quickly. Atlas needs to be a reliable member of the workforce, and this is one of the ways that we plan to do that. So let's talk about the AI brain. AI has been a huge topic, not just at CES today, but in the last few months and years in the media. I want to talk a little bit about how we're actually building the AI brain and what it really means to build an AI brain. The promise of AI for robotics is that they will be able to handle diverse manipulation skills. We'll be able to handle any object in a facility in any type of environment. And similar to a large language model, the more data that you feed Atlas, the more skills that it can do. But training Atlas is a little bit more complex than training a large language model because the types of data that you feed Atlas need to be different than the types of data that you feed a large language model. But you still need lots of data in order to have a large behavior model that really works. This is an example of Atlas performing an autonomous behavior that we trained it on. And it's an example of one of the types of behaviors that we can do with the robot when we train it. The training process looks a little bit different depending on the method we use. The first method of training Atlas is through teleoperation. This is physically embodying the robot with a VR headset on, with sensors on your hands and feet, and then you show Atlas how to do a task over and over and over again. And with just a few hours of data, you can train Atlas how to do a task all on its own. Part of the reason it's so straightforward is because Atlas has already done it. Pencils to torque. So when you build the policy, the robot has already seen it. The other way that we train Atlas is through reinforcement learning. Reinforcement learning is where we train Atlas in simulation. This is a much more scalable way for us to train Atlas because we don't need hardware in order to train the robot on a task. We can show Atlas how a human does a task, build that task in simulation, and then repeat it over and over and over again in simulation, building a really, really robust behavior because we can change the background, we can change the environment, and we can kind of agitate the environment in the same way that it might be agitated in a real factory. Maybe a forklift driver dropped off equipment 6 feet from where they were supposed to. The robot needs to be flexible enough to handle those conditions, and reinforcement learning and behavior cloning are both ways that we make Atlas resilient to real-life conditions. This is a video we released maybe a few months ago, and it's really cool, not just because Atlas is doing cartwheels and doing really athletic behaviors, but we can make Atlas do things we've never been able to make it do before with the advent of AI, with reinforcement learning. And we can make it walk and move in a way that's much more human than you've seen before. We announced our partnership with Google DeepMind on Monday, and this partnership is very, very exciting for us because we're able to take the power of the Google DeepMind team and the Gemini team and really apply that to robotics and provide our customers with the value of having more out-of-the-box intelligence for Atlas on day one, making it easier for Atlas to have a semantic understanding of the world so that when it arrives on site, it generally knows what it's looking at. It's faster to map, and it's faster to train Atlas with new behaviors. But we talked before about the fact that we need more than just an AI brain and more than just hardware to build a product. A product is an actual solution in customer facilities. It's supposed to solve a problem. In order to actually build a product with a humanoid, it can't just pick things up and put it down. We need Atlas to follow the rules of the road in your facility. You need to be able to train Atlas the way you train a person. You need to be able to integrate Atlas into your systems. You need Atlas to know who to call and what to do if it runs out of inventory, or if it scans a barcode and the supplier put the wrong barcode on the part and now it won't work. These are all problems humans run into, and Atlas needs to be robust, just like a human is, dealing with all of these exceptions. You also need great operator tools and interfaces. Atlas has lots of data on board, and we want our customers to be able to interface, intervene, understand how Atlas is doing, and take advantage of that data to optimize their business over time with that historical data. That's all going to run on our Orbit system that Spot uses today, and we're going to take that software that we already use in thousands of customer facilities and actually allow our customers to then use Orbit to train Atlas and to understand what it's doing. But I know you're all wondering, when can I use Atlas? So when are you going to bring all of these pieces together to actually deploy a product, and when can I use it in my facility? The answer is, we have a little bit of a ways to go. In 2026, we are going to be heavily focused on making Atlas smarter and more reliable. We're going to be training Atlas on real-world factory data in Hyundai, Google, and Boston Dynamics labs. So all of our inventory for 2026 is going to be focused on that. So that in 2027, when we go to customer sites around the world, we're bringing a robot on site that's reliable and smart. In 2027, we're going to be learning from the customers that we partner with about how we build out an application layer that operators love to use and love to work with. If you're interested in being part of that experience, if you're interested in actually building out a product with a humanoid, and if you think that you have a place in your business where a humanoid makes sense, please let us know. We want to hear your use cases. We want to hear where you think Atlas makes sense in your facility. You can go to bostondynamics.com and let us know where you think Atlas would make sense in your facility to get a conversation started. I hope that provided a little bit more insight into what we're thinking at Boston Dynamics, what our long-term vision is, and what the path looks like ahead to getting there. Thank you so much for joining me today. It was great having you all. Thank you so much.
Every step forward.
Good. So, just extra revolution. Jumped out.